This is the Dive Into Discovery podcast, where curiosity meets insight, and every conversation uncovers a new layer of understanding.
Welcome to another deep dive. This time, we're heading to the outer edges of our solar system to explore the mysterious Planet 9. Could there really be a hidden giant lurking out there, shaping the orbits of everything around it?
What makes this so fascinating is the sheer scale of it all. We're not just talking about some asteroid. This could be a planet 5, maybe even 10 times the mass of Earth, with an orbit so huge it makes Neptune look like it's practically hugging the sun.
Okay, that's a seriously massive planet. And you're right, that orbit, tens of thousands of years for a single trip around the sun. If it exists, it might have only gone around a handful of times since the Big Bang. That's mind-blowing. But how do we even begin to search for something so far away, something we can't even see directly?
Well, it's like finding clues at a crime scene. We see the effects, the aftermath, and we have to piece together what happened. In this case, our crime scene is the Kuiper Belt, that region beyond Neptune that's full of icy leftovers from the early solar system. And some of those leftovers, those Kuiper Belt objects, are acting very, very strangely.
Strangely, how? What's got astronomers so puzzled?
It's their orbits. Instead of being randomly scattered, which you'd expect way out there, some are bunched together, elongated, and pointing in roughly the same direction. Imagine playing pool and suddenly a bunch of the balls all move in unison. You'd assume something hit them, something you didn't see, right?
Yeah, you don't just see that happening by chance.
Exactly. And it's the same with these Kuiper Belt objects. It's incredibly unlikely for them to have these synchronized, peculiar orbits without something influencing them. And the most likely culprit, a hidden planet, Planet 9.
So this hypothetical Planet 9 is like a cosmic shepherd, using its gravity to herd these icy objects into these strange paths.
A fantastic analogy. Just like a shepherd guides their sheep, Planet 9's gravity, even from a huge distance, could gently nudge these objects over billions of years, shaping those unlikely orbits we observe today.
It's not just that the orbits are weird, it's that they're weird in a synchronized way, suggesting a single massive influencer. So we could be talking about a whole new planet in our solar system, a giant one at that. What else do we think we know about this potential heavyweight?
Well, based on the gravitational effects, astronomers estimate it could be 5 to 10 times the mass of Earth. Probably a gas giant like Neptune, but significantly bigger.
Yeah.
And get this, its orbital period, the time to circle the sun, could be anywhere from 10,000 to 20,000 Earth years.
Whoa, so while Neptune is out there taking its time, Planet 9 is practically in slow motion.
You could say that. Think about it. The last ice age on Earth ended about 11,700 years ago. So Planet 9 might have only finished maybe 1.5 laps around the sun since then. It's almost impossible to wrap your head around timescales like that.
No kidding. And some scientists even think Planet 9's influence might explain why our entire solar system is tilted.
It's an intriguing theory, to be sure. Our solar system's planets orbit the sun on a slight tilt, about 6 degrees compared to the sun's equator. And a massive planet like Planet 9, with its own potentially inclined orbit, could be the culprit. Imagine a bowling ball subtly influencing other bowling balls on a tilted lane. Over billions of years, that influence adds up.
So not only is it massive and slow, but it might have made our solar system a little wonky too. I can see why this is such a captivating mystery, but the big question is, how do we find this thing?
Astronomers have some clever tricks up their sleeves for hunting hidden worlds. And this is one case where they'll need every bit of that ingenuity. One of their most valuable tools is the concept of gravitational lensing.
Okay, I've heard that term before. Break that down for me. What is gravitational lensing, and how does it help us find something that's practically invisible?
Imagine a cosmic magnifying glass. That's kind of what Planet 9's gravity could do to light from distant stars.
Hold on, so instead of looking for Planet 9 itself, we're looking for the way it distorts the things behind it, like looking for its shadow, in a way.
Precisely.
Yeah.
Even though we can't see Planet 9 directly, its gravity, according to Einstein's theory of general relativity, can actually bend the fabric of space-time. And that bending can cause light from a background star to brighten temporarily as it passes by.
Wow, we're talking about using the warping of space-time itself to find this planet. That's some next-level astronomy. So what are the actual tools and techniques they're using to look for these subtle distortions and flickers?
Well, one key player is the Subaru telescope in Hawaii. It's one of the largest in the world, and astronomers are using it to scour the skies for any telltale signs of our elusive planetary neighbor.
So they're essentially looking for a cosmic needle in a haystack, except the needle is a planet that could be bigger than Earth, and the haystack is, well, the entire universe.
It's a monumental task, for sure. And the challenge isn't just the sheer size of the search area. It's also that Planet 9, being so far from the sun, is incredibly faint. It's like trying to spot a firefly in the middle of a fireworks show.
And to make things even more difficult, we don't even know where in its massive orbit Planet 9 might be. It's like trying to find a specific grain of sand on a beach.
Exactly. But luckily, astronomers are a resourceful bunch. They have another ace up their sleeve, the Vera Rubin Observatory. This observatory is designed to scan the entire southern sky every few nights, essentially creating a cosmic time-lapse.
So instead of staring at one tiny part of the sky, they'll have this amazing tool constantly watching, capturing everything. That's incredible. Tell me more.
It's like having a cosmic security camera monitoring the night sky for any suspicious activity. By comparing images taken on different nights, they can spot anything that's moved against the background of stars.
I can picture it now. We're looking at these time-lapse images, and suddenly this faint point of light has shifted. That could be Planet 9 slowly making its way across the cosmos.
Exactly. And while Vera Rubin is busy scanning invisible light, we have another powerful ally, the James Webb Space Telescope, or JWST, which sees the universe in infrared light.
Ah, the JWST, everyone's favorite space telescope these days. I bet it has a part to play in this cosmic mystery. But didn't we say Planet 9 would be incredibly cold and faint? Wouldn't that make it tough to detect, even for a powerful telescope like JWST?
You're right, it would be very cold. But even the faintest heat signatures don't escape JWST. It's like having super-sensitive night vision goggles that can pick up the tiniest bit of warmth, even in the coldest, darkest parts of the universe.
So let me get this straight. We've got ground-based telescopes like the Subaru looking for those tiny flickers and distortions of light caused by gravitational lensing. We've got the Vera Rubin Observatory, our cosmic time-lapse machine, ready to catch any moving object lurking out there. And then there's JWST with its incredible infrared vision, hoping to catch a hint of heat from this elusive world. It's an all-out cosmic stakeout.
It's truly remarkable, isn't it? This incredible combination of instruments, driven by the curiosity of scientists all over the globe, really highlights just how far we've come and the incredible things we're capable of achieving.
It's awe-inspiring, to say the least. But I have to ask, even with all this incredible technology, what if, and I can't believe I'm saying this, what if Planet 9 doesn't exist? There has to be another explanation for those strange orbits in the Kuiper Belt, right?
Of course. Science is all about exploring every possibility, testing every assumption, and considering alternative explanations. Not everyone's convinced that a giant hidden planet is the answer to this puzzle. Some think a more plausible explanation might be the collective gravity of many smaller objects in the Kuiper Belt. It's true, the idea of a whole bunch of smaller objects instead of one big Planet 9 tugging on those Kuiper Belt objects might seem more, well, reasonable at first. After all, we know the outer solar system is jam-packed with smaller bodies.
Yeah, it's like instead of one burglar, you're saying maybe it was a whole flash mob that caused the chaos, right?
Exactly. But there's a snag. The math gets a little, well, messy when you try to make that work. Simulations show you'd need a mind-boggling number of these smaller objects, all crammed into a relatively small space, to create enough combined gravity to match what we see.
So not impossible, but it's getting to be one of those theories where you need a whiteboard full of diagrams and a dozen red strings just to connect all the dots.
You got it. And while the collective gravity theory has its fans, there's another even more radical idea floating around, one that has physicists questioning if we even fully understand the laws of physics themselves.
Okay, now you've got my attention. Don't tell me we're going full-blown Matrix here, bending the rules of reality to fit our theories.
Not quite. But we are stepping into the realm of theoretical physics. What if, some physicists propose, instead of needing a new planet or a zillion tiny ones, what we actually need is to adjust our understanding of gravity itself?
Interesting. You're suggesting the answer to this mystery might not be a who, but a how. Tell me more about this alternative gravity theory.
Well, it involves looking at possible modifications to Einstein's theory of general relativity. You see, general relativity has been incredibly successful so far in explaining how gravity works on a large scale. Things like how starlight bends around massive objects, or even how the universe is expanding. But there are a few areas, especially at huge distances or in really strong gravitational fields, where general relativity seems to, well, not quite add up.
You're talking about things like dark matter and dark energy, right? Those mysterious somethings that seem to make up most of the universe but don't interact with light in any way we can detect.
Exactly. And some physicists believe that by tweaking the equations of general relativity, just slightly, mind you, we might be able to explain these inconsistencies without needing to invent exotic new particles or forces. And one of the interesting consequences of these modified gravity models is that gravity itself might behave differently at vast distances.
Hold on. So instead of needing Planet 9 to explain those strange Kuiper Belt orbits, these physicists are suggesting that maybe, just maybe, gravity itself acts a bit differently out there on the edges of our solar system.
That's the gist of it. It's like the rules of the game change slightly when you're playing on a pool table the size of, well, the solar system.
That's a pretty mind-bending concept. So, to sum it up, we've got this potential cosmic conspiracy of smaller objects working together, a potential rewrite of how we understand gravity itself, and of course the ever-elusive Planet 9. It's a cosmic game of Clue, except the suspects are celestial bodies and theoretical physics.
And just like in a good mystery, we have to carefully examine all the evidence, line up all the suspects, and follow the clues wherever they lead. And right now, the evidence for Planet 9, even if it's circumstantial, is still the most convincing explanation for many scientists.
It's that classic detective movie moment where they slap a photo on the board and say, "This is our guy, but we need more evidence to put them away for good."
Exactly.
Yeah.
And that's what makes this whole search so exciting. We're all on the edge of our seats waiting for that definitive proof that either confirms Planet 9 once and for all or sends us back to the drawing board.
It makes you want to grab a telescope and start searching the skies yourself. But seriously, you've done a fantastic job explaining why this search is so important to the scientific community. But you know me, I always like to bring it back to our listeners and their own sense of cosmic wonder.
Please do. Sharing the wonders of the cosmos is what I live for.
So let's say you're not an astronomer, you don't spend every night glued to a telescope, and you're perfectly content with the 8 planets we've got. Why should you care about a hypothetical 9th planet billions of miles away? What makes it so important to the average person?
That's a question I get a lot, and I love answering it.
Yeah.
Because the search for Planet 9, whether or not it actually exists, has already taught us so much about the outer solar system. It's like finding a secret room in your house you never knew existed. It changes your entire perspective.
It makes you wonder what else might be hiding just out of sight.
Precisely. But beyond just the awe and wonder of discovery, there are even deeper implications. Think about the history of science for a moment. How many times have we thought we had it all figured out, only to stumble upon a discovery that completely changes everything?
Like that time we realized, much to our ego's dismay, that the Earth wasn't the center of the universe. That was a big one.
Exactly. And discovering Planet 9, or even conclusively proving it doesn't exist, would have that same kind of impact. It would force us to re-examine our entire understanding of how planetary systems form, how they evolve. It would teach us about the early solar system, a time of cosmic collisions and migrations that ultimately created the solar system we know today.
So it's not just about one planet. It's about what finding it, or not, tells us about the bigger picture of how solar systems work.
You've got it. It's about pushing the boundaries of our knowledge, questioning our assumptions, and embracing the sheer scale and mystery of the universe we live in.
It's both humbling and exciting at the same time, wouldn't you say? But let's talk specifics. What would actually count as definitive proof of Planet 9's existence? What are astronomers looking for that would make them shout from the rooftops, "We found it! Planet 9 is real!"
The Holy Grail, the ultimate proof, would be a direct image. Even though it's incredibly faint and distant, if we could capture a picture of Planet 9, even a single pixel of light, that would change everything.
I can see the headlines now. Planet 9 found, astronomers capture first ever image. It would be huge.
No doubt about it. It would be a landmark event in astronautical history. But even without a direct image, there are other pieces of evidence that could strengthen the case for Planet 9 significantly. Remember those clustered orbits in the Kuiper Belt that first hinted at its existence?
Of course, it's like a trail of cosmic breadcrumbs leading us to this hidden world.
Exactly. If astronomers continue to find more and more objects with those same strange aligned orbits, those breadcrumbs start to form a much clearer path, making the case for Planet 9 even stronger.
So every new object we find that fits the pattern adds another piece of evidence towards the existence of this hypothetical world.
Precisely. But it doesn't stop there. Gravity, as we know, affects everything. And Planet 9, if it's out there, should be leaving its gravitational fingerprint on other objects in our solar system as well.
Okay, now you're really making me think. You're saying even if we can't see Planet 9 directly, we might be able to detect it indirectly by how its gravity affects other celestial bodies. Talk about long-distance detective work.
You got it. We're talking about looking for subtle wobbles and deviations in the orbits of other objects, maybe even tiny changes in the tilt of the sun's rotation axis over incredibly long periods. These faint gravitational whispers, so to speak, could be the key to pinpointing Planet 9's location.
So Planet 9 is like this invisible puppet master subtly tugging on the strings of our solar system, and we're trying to figure out where it is and how big it is just by watching how the puppets move.
That's a very poetic way to put it.
Yeah.
And surprisingly accurate. It's really quite amazing when you think about it, that we can even conceive of detecting a planet not by seeing it directly, but by sensing its gravitational influence on its surroundings. It's like, how should I put it? It's like knowing a ghost is present by the way it makes the room feel colder.
It really is mind-boggling. We started this deep dive caught up in the mystery of those strange Kuiper Belt orbits, and we've gone from rogue planets to alternative gravity theories, and now we're talking about tracing the faintest whispers of gravity across billions of miles and billions of years. It's a lot to take in.
And to think, it all stems from this very human desire we have to explore, to push beyond what we know, to unravel these cosmic mysteries.
You know, it's funny, we started out talking about Planet 9 as this potentially menacing object hiding in the outer reaches of our solar system. But as we've dug deeper into this deep dive, I've realized it's about so much more than just the possibility of another planet. It's about the awe and wonder of exploring the cosmos, the thrill of the chase, the pursuit of knowledge itself.
I couldn't agree more. The search for Planet 9 has really reignited our fascination with space. It reminds us that there are still mysteries to be solved right here in our own cosmic backyard. And that's incredibly exciting.
It certainly reminds us that the universe is full of surprises. And who knows, maybe one day, thanks to all these brilliant minds hard at work, we will be able to officially add another planet to our cosmic family portrait.
Wouldn't that be something? But even if Planet 9 turns out to be a mirage, a figment of our scientific imagination, the journey itself has been incredible. We've learned so much about our own solar system, the intricacies of gravity, and the boundless potential of human ingenuity.
You've definitely given us a lot to ponder. It's amazing how much there is still to discover, even in a place we thought we knew so well. And who knows, maybe, just maybe, way out there, in the silent depths of our solar system, Planet 9 is waiting to be found.
It's a tantalizing thought, isn't it? And as we continue to explore, to build bigger telescopes, to develop even more sophisticated techniques, I have no doubt we'll continue to make amazing discoveries. Discoveries that challenge our understanding of the universe and our place in it.
I can't wait to see what we find next. And to all our listeners, we hope this deep dive has sparked your own cosmic curiosity. If Planet 9 does exist, what wonders might it hold? Could it have rings, moons? Could those moons even harbor life?
Now, those are some great questions. And while we don't have the answers just yet, that's the beauty of science, isn't it? Daring to ask the big questions, to imagine the possibilities, however improbable they might seem. Who knows what other secrets our universe holds, just waiting to be uncovered.
Well said. So keep exploring, keep asking those big questions, and never lose your sense of wonder. Until next time, keep looking up.
What did you think of this week's episode? We'd love to hear your thoughts in the comments. Don't forget to join us next time as we dive even deeper. And as always, stay curious, because you never know what discoveries are just around the corner.